Hello everyone, my name is Eduardo. I'm an incubation engineer at GitLab working on MLOps. And for the past few months, I've been working on incubating machine learning experiment tracking at GitLab. And today I want to give a bit of an overview of the current status and a little bit go over what is it that I am doing, what is the vision, and where we are at, what are the next steps, and so on. So, for starters, what is experiment tracking? When we work with machine learning, a machine learning model is usually seen as composed by three parts. For you to replicate, for you to recreate the same model, you need the same artifact, you need three pieces of information. First, the code that was used to create the model. Second, the data that was passed to the code, that the code learned the relationships from. And third, the hyperparameters, the configurations for the code, for the data, for the environment in itself. With these three pieces of data, we create a unique machine learning model. When a data scientist is creating a model, they often don't know what is the best hyperparameter set for that specific code and data. So what we usually do is we create we do a search, we create a set of possible hyperparameters, and we do a search over this for the same code, for the same data, and we set a lot of different hyperparameters, and each of those sets will create a different candidate. So a different candidate for a model that will be compared to the other candidates. This is called hyperparameter tuning. Now, beyond hyperparameter tuning, experiment tracking, we can have not only the hyperparameter being changed, but the code, the data in itself, the hyperparameter. Each one of these combinations will generate a candidate. And an experiment is a set of comparable candidates. So we will have pointers to the code, to the data, to the hyperparameter, and each one will generate a candidate that I want to compare against other candidates. And experiment tracking is a metadata registry that tracks the results of each of these candidates. So I can have multiple experiments with many hundreds of candidates, and I will be able to search, compare them as long as they follow some of the same comparison measures, so some metric that they all have in common. And how are we implementing experiment tracking? So the biggest player on the open source scene for experiment tracking is MLflow. It does a lot more than experiment tracking, but here I'm going to focus more on the experiment tracking part of MLflow. Some of the positive sides of MLflow is that it has a great client. So the client code that the data scientist uses to save on their code base is really great. It has a very large user base, open source, and a large number of other tools integrate with MLflow already. So deployment and some deployment tools already integrate with MLflow. The negative side, however, is that the corporate part, the corporate features that are often desired from a tooling, are not there. So there's no user management. There's no authentication with MLflow. This is one of the most requested features on their issue board. It needs setup. It needs a platform engineer to go there and deploy the server. It is an additional service, so they have to go deploy in Kubernetes or whatever and maintain the deployment. It's siloed information, siloed knowledge. Since it's its own tool, you can access through API, but you have to put effort to create integrations with your other operations. So how do we come in at this? What are our North Stars on how to approach this? One, we want to create an experiment tracking that for a GitLab, for a user that already has GitLab, there's zero setup. If you have GitLab, you have experiment tracking. That's the first step. And for the data scientist, beyond just having the GitLab experiment tracking, it will work with their MLflow, with their code that uses MLflow with minimal changes, preferably zero changes. So the only thing that we want them to do is change the endpoint. Instead of calling MLflow, call GitLab. And third, we want experiment tracking to be more than a vertical feature, a feature by its own. We want to reuse the information from the experiment tracking to improve the experience on, I don't know, merge requests, on issue creation, or issue listing, or I don't know, anywhere on that makes sense on the platform. So we want to leverage the power of the DevOps platform of GitLab, both to add into it and to use from it. And how does that manifest technically? One, so MLflow experiment tracking has two components. One, the client code, which is the code, the library that data scientists use to push information. So they are running their experiment, and it will call the MLflow library to send information to the MLflow backend, which is where it's stored, and where the UI and everything, where they can access them through the UI. So what we are doing, we are creating a replacement. We are making GitLab a replacement for this API. So instead of pointing to MLflow, the data scientists can just switch their UI and point to the GitLab backend. We are re-implemented the entire MLflow API into GitLab. The positive sides over here is that if the user has GitLab, then it works because they already have GitLab. They will have experiment tracking by default. Once we start working on it, it will be a lot easier to integrate across the platform. So integrate, display that information where it makes sense. There's zero work necessary by neither to set up MLflow itself or to set up artifact storage or anything. We are reusing GitLab for this. For the data scientist, nothing changes. The only thing that changes actually is that instead of pointing to MLflow, the URI of what they're calling, they now point to GitLab. And their code base will work exactly the same. The downsides here is that we need to keep API parity over time. Currently, we are supporting the MLflow client at 1.8, but MLflow is already at 2.0. So we need to keep the parity going. And the other downside is that we need to re-implement the whole UI. So, which makes the experience better for your user because it's more the same as it will be part of GitLab, so there's no difference in UI, but it's more work on our side. And how far are we? I have this demo that I'm linking here, but I'm not gonna go over it. The point is, GitLab already serves. We already re-implemented MLflow API on the GitLab code base. So you can already point your MLflow code to GitLab. We already have implemented the minimum UI for this, so you can already browse your experiments, browse your candidates, compare them. It's not as great as MLflow, of course, and we are now dogfooding this MVP with internally. So our data scientists are using it and giving feedback on what they want from it, what's necessary to add, and yeah. So we are at the point where we already have the MVP is ready and is already being used. What are the next steps? Where do we want to go over here? The next step is consolidate this MVP and now move from internal testing to external testing. This will happen in the next few weeks. And second, now that we have the feature done, the vertical part of the feature, we want to go horizontal. We want to see how that information can be leveraged on other places of GitLab, and how would that mean for the user? How can they help? How can they leverage this, for example, on the CI or on the MAR or anywhere really? And further links over here if you want to continue looking at it. So there's an epic, there's the feedback issue, all updates. I release updates bi-weekly, and the handbook page. As a bonus, some of the questions that and often a question that I get is, what is the difference between experiment tracking and model registry? model registry is being worked on at GitLab as well, not by me, but it is being worked on, and it does have a lot of similarities. So, going back, an experiment has all the different code bases, the code base, the data set, and the hyperparameters. Each one will be generating a model candidate. And some of these candidates will be promoted to models. So on the experiment tracking side, some of these candidates are creating even at the local machine of the user, right? And the models are some of these candidates, the best candidates that I keep finding over time, will be promoted to specific model versions. And these model versions will then be exposed to the real world, to the application. So the main difference between experiment tracking and model registry, they work together. On experiment tracking, the model candidates have not yet seen the outside world. They have not been exposed to user. So the metrics that you use to compare them are mostly model metrics. So accuracy or area under the curve, so more of the academic machine learning metrics. While the model registry, you actually put them in production and you can measure them against usage metrics. Like I said, on experiment tracking, none of the candidates are user-facing yet, while on the model registry they already are. The artifact creation on experiment tracking can both happen at the CI or they can happen locally. So a data scientist often creates those candidates not from the CI itself, but when they are coding, before even the first commit is created. While in the model registry, ideally, a model has always been created through a pipeline. There's another difference is that where is the stage? Where does each one belong in the MLOps/develop stage? For experiment tracking, they are more associated to the create stage. So when the user is still creating their code, still creating their machine, their ideas, while for the model registry, it's more on the packaging side. So you already have a model that you want to push to production. So you create a model over there. You promote a candidate into a model version. Yeah, and those are the differences that I had. So this is all I had for today. Thank you for watching and goodbye.